Good evening, class. So today I'll be doing topic B study guide. It's basically going over everything that we've done for this week plus some. Please pay attention to the strategies you see me do with some of the problems. I'll try to go as slow as possible. You always have the ability to rewind and fast forward, all the things with a video. Okay, so let's look at number one. Remember, with our questions, we want to box our verbs and underline what the verb is talking about. So when I read number one says, consider the equation 3 times 1.5x minus 0.75 minus 1 equals ax plus b. The equation has infinitely many solutions. What are the values of a and b? So my verb here would be consider. And what am I considering? The equation. All right. The other important information is that the equation has infinitely many solutions. We should know what that means by now. So then it says, what are the values of a and b? So the equation in the state that it is in is not at the stage or step where we can figure out if it has infinitely many, no, or one solution. We have to get it to step 3. So anytime you're solving an equation, and I'm telling y'all to do it for the test when you practice until you get used to what the steps are, we'll go through the steps. So step 1 is parentheses. Can I do what's in the parentheses? No, I cannot. So the other way to do parentheses is distribute. So I must distribute the 3, which means I'm multiplying 3 times 1.5, which would give me 4.5x. And then I'm also multiplying 3 times negative 0.75. Okay, remember you include what's in front of the number. So that would be negative 2.25 minus 1 equals ax plus b. Okay, so now I've done step 1. Now I'm at step 2. Step 2 is combine like terms. The question is, do I have like terms? And the answer is yes, because negative 2.25 and negative 1 are like terms. When we combine like terms, we combine them from left to right. So as in you read the problem that you're doing from left to right. So this would be negative 2.25 minus 1. So remember, when you minus a negative, it makes the negative greater. So this would be a negative 3.25. We still have 4.5x because we didn't do anything over with that, is equal to ax plus b. So now we are at step 3, which means we should be able to identify a and b. So for it to be infinitely many solutions, remember that it has to match perfectly on the other side. So that means a would have to be 4.5. You do not have to include the x, because if you look at a is next to x, 4.5 is next to x. And then b would be negative 3.25 or negative 3 and 25 hundredths. Okay? Pretty simple and straight to the point. Let's move on to number 2. So number 2 says Nora and Henry each build a robot that climbs a rope. Nora's robot starts 1 foot above the ground and climbs 20 inches every 45 seconds. Henry's robot starts 2 feet above the ground and climbs 10 inches every 30 seconds. Both robots start climbing at the same time and climb for s seconds. Part A. Part A says write an equation that can be used to find the number of seconds that the robot must climb to reach the same height. Okay, so to do part A, we have to think about the things that we talked about with lesson 11, where we're coming up with scenarios, or we have like real life situations that are set up to be equal to each other, where the variable is talking about the same real life item, where S is talking about seconds. Okay. So we know automatically that our equation should have an equal sign in the middle, because both things are equal. Nora's thing and Henry's thing needs to be equal because we're trying to figure out where they are at the same spot. Okay, so if we break down Nora's information, it says Nora robot starts a foot above the ground. So normally in my head, I would want to do a +1 because, okay, it's 1 foot. But if I continue reading the problem, I'll see that it says it climbs 20 inches per second. So since when they talk about it climbing, they're using inches, just to make sure all of my measurements are talking the same way, I will want to change feet or the foot to inches because that's an easier conversion. If I try to change 20 inches into feet, it would be like a mixed amount, and we don't want to do that, okay? So to represent the 1 foot, I can go ahead and put a +12 because there's 12 inches in a feet or in a foot. Now I just have to figure out how to represent the 20 inches every 45 seconds. So something that we're experimenting now, but we're going to learn more about in the next topic, they are basically introducing you into unit rate. So we need to figure out how fast the robot is moving per 1 second, okay? And in order to do that, we would have to set up the fraction 20 over 45, where you're dividing the amount of distance it goes by the time. Because when you do that, that will give you, the result that you get will be how fast the robot is moving per 1 second, okay? So once again, we don't really want to divide this fraction because it's going to give us a decimal weird number, but we can simplify it. If we simplify it, we can divide it by 5, okay, to make this 4/9. So that means in front of the +12, which I'm just going to make it look better, it would be 4/9 S plus 12. So all of that represents Nora's robot. Okay, so now if we take the same thought process that we gave with Nora's robot and we bring it to Henry's robot, Henry's robot started 12 feet above the ground, so we know that would be a plus of 24 because, 12 times 2 is 24. There's 12 inches in a foot. And then if we do the same thing we did for his robot moving at the speed that we did for Nora's robot moving, that would be 10 over 30, which can reduce by 10, okay, which would make the fraction 1/3. So it would be 1/3 S, okay, plus 24. This would be the equation that you can use and solve in order to figure out part B, which part B says after how many seconds will the robots be at the same height. Okay, so as I just said, we would have to solve that equation in order to figure out how many seconds the robots could be at the same height. So I'm really glad that we have this problem because it gives me an opportunity to reintroduce or reuse the method of multiplication property of equality, okay? So if we don't remember what that is, remember if, and I hope you're listening to me when I say this, if your coefficients, that means the number that is in front of the variable or attached to the variable, if they are fractions, you can make them whole numbers by using the multiplication property of equality. What is the multiplication property of equality? So all that is saying that all of this over here is going to equal something. I'm going to call it A. All of this over here is going to equal something. I'm going to call it B. A and B are said to be equal to each other according to the equation. So I should have the ability to multiply B times a number and A times that same number, and they should still stay equal. But in doing that will help me get whole numbers instead of be using fractions. Okay? Very simple concept. So now, in order to figure out what number you want to multiply your fractions by, you need to look at the denominator of your fractions. So what you're going to look for is a common product, which means that is the answer after you multiply for those two numbers. And not the highest common product, but you want the lowest possible number you can use. Okay, so initially I know a lot of people will say 3, but there's nothing you can multiply times 9 to get 3. So the next option would be 9, which would be correct because 9 times 1 is 9, 3 times 3 is 9. Okay, so now we are multiplying both sides, or basically the entire equation, by 9. So we are distributing 9 to everything in the equation. Okay, so on this side over here, that would be 9 times 3 over 1. So 9 times 3 over 1 would equal 9 over 3, which if you reduce it would be 3s. Then 9 times 24 would be 216. Okay, equals. Then over here on this side, you have 9 times 4 over 9. Okay, so remember, I told you guys, and please remember this because this is how you get rid of a fraction if you need to get rid of it, or basically break it down. If you multiply any fraction times its denominator, it will eliminate the denominator and leave you with the numerator. So basically what happens on this side, when you do this multiplication, these cancel out, right, with the butterfly method, and it turns into 4. So that means over here you have 4s plus 9 times 12 is 108. Okay, so now we have whole numbers and our problem should be easier to figure out. So if we go through our steps, because we are still solving an equation now, we are on special step 3, which means that we have to get rid of one of the variables. Remember, we get rid of the variable that will give us a positive coefficient. Just in case you don't know what that means or what that looks like, if I tried to get rid of 4s, this is going to cancel out, but I know that 3 minus 4 is negative s. So that is not what I want to do. That is not what works. So I should get rid of 3s, because if I get rid of 3s, I know this cancels out. And then 4 minus 3 is 1s, or just s by itself. Okay, that's what I mean when I say you want a positive answer. We didn't do nothing with the plus 108, so it's still there. Equal sign still there. Didn't do nothing with the plus 216. So now we got to get x by itself. To get x by itself, we have to just get rid of the 108, which we would subtract because we do the opposite. So 108 is gone. So that means s equals 216 minus 108, which is s equals 108. So that means it takes 108 seconds for the robots to equal or be at the same height. I'm going to apologize in advance to my 6th period class because I know we tried to do this problem in class and we got all jumbled up, but this would be the proper way to do the problem. So please rewatch this process and study it as much as you need to, so that way you have a better comprehension of how the problem works. Okay, but let's move on to number 3, where we have a good bit of work to do there too. So now in number 3, it says that Dylan uses butter to bake cookies and muffins. He uses 5/8 cup of butter to make 1 batch of cookies. He uses 3/4 cups of butter to make 1 batch of muffins. Dylan has 3 3/4 cups of butter to make 2 batches of cookies and 3 batches of muffins. What else can Dylan make with the leftover butter? So breaking this problem down, we first, if we analyze the problem, need to figure out how much butter Dylan has left from the 3/4 butter that he had. So in order to figure out how much butter he had left, we would have to look at what he made. He made 2 batches of cookies and he had made 3 batches of muffins. So I know a batch of cookies takes 5/8, and I know that a batch of muffins takes 3/4. But so the way I'm talking about the same thing, right? Because I also know that he has 3 3/4 of butter that he's using. To make it when I'm talking about the same thing and everything looks the same, I will want to find a common denominator. So before I find a common denominator, let me change this this mixed number into an improper fraction. So 3 times 4 is 12, plus 3 is 15. So that would be 15 over 4. Then I will want to find a common denominator between all 3 of these fractions. The common denominator would be 8 because we can move up when we're finding a common denominator, but we cannot move down. So I will multiply the 2 that don't have 8 by 2 to get 8 as a denominator, which means the amount of butter that he would be using would be, I'm going to write it over here, would be 30 over 8, okay, because that's when I did this over here. And then this one can stay the same, but then this one would be 6 over 8. Okay, so now to make sure we're all on one accord, we're using 5/8 butter to make a batch of cookies. We're using 6/8 butter to make a batch of muffins, which is the same thing as the 3/4. And altogether, the amount of butter he has to use is 3 3/4. But as a improper fractions, that would be 15 over 4. But we changed it to a common denominator, and it's 30 over 8. Okay, so now we can just make sure that we use the right amount of butter. So if one batch of cookies is 5/8, to make it 2, we would multiply that times 2, which would give us 10/8. And then same thing with the muffins. We know how much it is for 1, so we will multiply it times 3 to get 18 over 8. Then we can add the 18 over 8 and the 10 over 8 to get 28 over 8. And we would subtract that from the amount of butter he had to give us 2 over 8, or 1/4. So he has 1/4 amount of butter left, and we need to figure out what that amount of butter can get him. Okay, so now that we know how much butter he has left, we can look at our answer choices and see how much cookies or muffins or whatever they're saying that he can make. Okay. So if I look at the first one, it's saying that he should be able to make 1/3 batch of cookies. So that means we would be taking the recipe and cutting it into thirds or dividing it by 3. So if I take how much butter it takes to make 1 divided by 3, of course we're dividing fractions, so we do keep, change, flip. Okay, you keep the same fraction, change from division to multiplication, and then flip the last fraction. That would be 5 over 24. I cannot reduce this, but I also do not have enough butter, or I have too least butter. Okay. So now if we do the next one, it's the same thing. I'm dividing it by 3. So once again, we would go through the same process of the keep, change, flip, which would be 6 over 8 times 1 over 3, which would equal 6 over 24. I can reduce this fraction by 6 at the top and the bottom to get 1/4. Okay, so I can actually stop here, because if I need 1/4 butter to make 1/3 batch of muffins, this problem only has one answer according to what it is asking me. That is the same amount of butter he has left, so I have found my answer. Okay. So let's go through number 4 real quick and number 5, because that's the easy stuff. That's the stuff we've been doing. So number 4 says solve each equation to get the given answer. So there's 2 ways you could have did this. My smart people who think about less work versus more work, you could have just plugged in each answer choice into the problem and see which one worked. If you got the same number on both sides, that means that answer choice was right. But for my people who, want to do the process, and I'm not mad at you wanting to do the process, you just solve the equation like we know how, and I'm happy to see that. So if we solve the first one, we had to go through the steps like I said, we always do. So first we would have to distribute, because that is step 1, or step 1 is parentheses, but we can't do the inside, so then we distribute. So we distribute our numbers on the outside of the parentheses for both of these. That would give us 6x plus 18 is equal to 8x plus 6. So once we get right here at special step 3, we can look at it and tell how many solutions we should have. We should have 1. So now we got to keep solving it. The better number to get rid of would be the 6x. So if I minus 6x on both sides, this will go away. So then I'll have 18 is equal to 2x plus 6. Then I have to get rid of the plus 6 by minusing 6. So this will go away over here. Then that would be 12 equals to x divided by 2. Divide by 2. The first answer should be a positive 6. Okay, so now if we do the next one, we go through the steps. Do we have to do step 1? Yes, we do. So we would distribute. So that would be 6x equals 3x minus 21. So now we have to get rid of one of the x's because we're at special step 3. We would get rid of 3x because that will put us in a positive. So this goes away. That would be 3x equals negative 21. Divide by 3 on both sides. X should equal negative 7. And then finally, the last one, please pay attention to how this happens. So yes, once again, we do have to do step 1, but we will distribute the negative 4, not just 4, because remember, you have to include what is in front of it. So then that would be 3x minus 8 minus 4 equals 26. We combine like terms because we do have to do step 3. 3x minus 8 would equal a negative 5x minus 4 equals 26, plus 4 to get rid of the minus 4. So then you have negative 5x is equal to 30. Then you divide by negative 5 on both sides, and you should see that the final answer is negative 6. Okay, very simple. If you need me to slow down and do it again, just go and rewind the video. But we should already know that. We've been doing that enough. I think we should have that fluently done. Okay, and so then finally, number 5. Number 5, we only have to get to special step 3 because that's the step that we get to when we can figure out if it has one, infinitely many, or no solutions, okay? So we don't have to do nothing to the first one because it's already in special step 3, but we have to know how to check. So the first thing I told y'all to check is your linear terms. If I check my linear terms on both sides, I have a positive 5x and a negative 5x. Those are different, so that means I have one solution. Because remember, if the linear terms are different, you have one solution. Very simple. So now if I do number 2, I have to distribute first before I can get to special step 3. So that means I would distribute here. So that means it would be 2x plus 6 is equal to 2x minus 6. All right, so now I'm at special step 3. If I check my linear terms, they are both a positive 2, but remember, when they're the same, you have 2 options. So now we have to check our constants. Our constants are different, so that means we have no solution. If our constants were the same, though, we would have infinitely many solutions. All right, so now if I do the next one, once again, I'm at step 1. I have to distribute on both sides. So that would be 6x minus 9 is equal to 6x minus 8 minus 1. So then we have to do step 2, which is combine like terms. Negative 8 minus 1 would be a negative 9 or a minus 9. Still have 6x. Still have 6x minus 9. It is the exact same thing on both sides. So that means I have infinitely many solutions. And then finally, the last one I'm doing the same thing. I gotta distribute first. So that would be 4x minus 20 plus 2x is equal to, when you distribute a fraction. So remember, when you multiply times a fraction, it makes the number smaller in the first place. But more specifically, when you multiply times a fraction that has a numerator of 1, all you're doing is dividing whatever number you're quote-unquote multiplying it times by that number, by the denominator, okay? So 1 4 times 16 is basically the same thing as 16 divided by 4, which would give you 4x. Same thing with 12, so that would be negative 3. So now I'm on step 2 again. I have to combine like terms. I would be combining 4x and the plus 2x, so that would be 6x minus 20 is equal to 4x minus 3. So now that I'm here, I can compare my linear terms and see that they're different to know that I only have one solution. Okay, so that should be really easy work. It's partially solving equations, but we don't have to finish solving them out. We should be used to that by now. And then finally, they want us to solve for D. So we have an opportunity once again to use the method that I showed you in number 2, I think it was, where we would multiply the entire thing by a number that matches the coefficients or gets rid of the coefficients fractions. So the fractions have in common 5. So I will multiply everything times 5 in the problem, okay? So when I multiply everything on the outside of the parentheses times 5, actually, not everything times 5, just the things in the first set of the parentheses times 5. Okay, so if I multiply this times 5, this cancels out to give me 2d minus 4 equals 3, open parentheses, d plus 2. It's going to cancel out there to give me negative 4d. All right, then I distribute again on both sides. So then that's 4d minus 8 equals 3d plus 6 minus 4d. Combine like terms on this side. Can't forget the minus. So that would be 3d minus 4d, which gives me negative d plus 6 equals 4d minus 8. So now I have to get rid of one of my variables. I'll do plus d on both sides, plus d plus d. This cancels out, so that give me 5d minus 8 equals 6, right? So actually, let me say I did make a mistake. So when I distributed this 5, I was supposed to distribute it to that 3 too, because that 3 was inside of that parentheses. So this 3 really should be a 15. And then that would make this 2 turn into a 30. Okay, so I'm still have the same work, but you see how I'm just correcting where my mistakes are. So now this should be a plus 30 and not a plus 6. Same thing down here, this should be a 30. So now I can do the right thing, plus 8. So you see how when you have your work on the screen, you can easily go back and correct it when you're wrong. Okay, I want everyone to notice that. You see how easy I went back and corrected my work with it being incorrect. Very, very easy task, okay? So then divide by 5. So D would equal 38 over 5. All right, so that's basically all you need to know for these topics and for the test. If you have any other questions or you're concerned about any other specific topic, lessons 7, 8, 9, and 10 are the ones for this study guide and for this topic test. Thank you and have a great day. Make sure you study because you know that the test will be timed tomorrow.